Hey guys, Mr. McKinney here, just finishing up our videos on L'Hopital's rule. This video will go over exponential and logarithmic examples. And again, when we talk about L'Hopital, really, Mr. Bernoulli invented it. And again, talk to Mr. Janssens if you want the details on that. So going back to our last set of videos, L'Hopital's rule says that if you have a limit that has a quotient in it, if both the top and the bottom evaluate to 0, so the limit of the top is 0 and the limit of the bottom is 0, you can use L'Hopital's rule, and the limit of the original fraction is the same as the limit of the derivative of the top and the bottom. Note, this is not the quotient rule, because the quotient rule has a much different formula, and the quotient rule doesn't have to do with limits. The quotient rule has to do with taking derivatives. This also works if the top and the bottom are both infinity. And in different calculus courses, you'll get into 0 to the 0 or infinity to the power of infinity. There's other versions. In calculus AB, we're only worried about 0 over 0 or infinity over infinity. So we won't be worried about these forms in this course. Everything will be a fraction. It'll either be 0 over 0 or infinity over infinity. It doesn't matter if they're both positive or both negative or one of each, as long as they're both an infinity. All right, so let's go through a couple of examples. So right off the bat, notice that instead of going to 0, we're going to infinity on this limit. So if I plug in infinity squared, that's going to be infinity, in this case negative infinity. Infinity squared plus infinity, that's also going to be infinity. Again, I don't want to write equals infinity over infinity. I want to write out the limit statement for the top and for the bottom. So the limit as x approaches infinity of negative 5x squared plus 2, that would equal negative infinity. The limit as x approaches infinity of 2x squared plus 7x plus 3, that would equal positive infinity. Just like if they're both 0, if they're both infinity, you can invoke L'Hopital's rule. So you can say LHOP rule applies, or L'Hopital rules applies, or just as long as you write LHOP somewhere, you'll be fine. If you've written out these two parts and write LHOP somewhere, they're going to know what you mean. So I'm going to say this is equal to the limit as x approaches infinity. And then let's take the derivative on the top. So that would be negative 10x. And then on the bottom, I would get 4x plus 7. When I plug in infinities, I still have infinity over infinity. So I would have to do another level. So I'm going to switch colors. Let's go to orange. Limit as x approaches infinity of negative 10x is negative infinity. Limit as x approaches infinity of 4x plus 7 is positive infinity. Since they're both infinity, we can use LHOP again. So this is the same as the limit as x approaches infinity of derivative on the top is negative 10, derivative on the bottom is 4. And this doesn't have an x to plug in, so this is equal to negative 10 over 4, which would reduce to negative 5 halves. On the AP exam, they would likely want to see the work for LHOP, but a way to check this is to think about end behavior. So if we think back to pre-calculus or at the start of the year, we talked about problems like this. If the largest exponent is the same, then the horizontal asymptote is going to be equal to the coefficient simplified. So this negative 5 halves ends up being the answer. If it was multiple choice, you can just think about end behavior. If it was on the free response, you would likely need to show the limit work as I did here. All right, let's do a couple more examples, getting into logs and then exponents. So first thing I want to do is see if I can just plug in infinity. So I'd have infinity on the top. Natural log of infinity is also infinity. And when you're working on problems which are natural log, it's helpful to think about what the parent function looks like. So first of all, you only have positive x values. It's not defined for 0 or for negative x values. And as x approaches infinity, this function is approaching infinity. It's not going up as quickly as it's going over, but it is going up and over forever. So I'm going to write out the limits for the top. Again, don't write equals infinity over infinity. Write out two separate limit statements. So the limit as x approaches infinity of x minus 1 is infinity. The limit as x approaches infinity of ln of x is also infinity. Therefore, we can use L'Hopital's rule. So I take the derivative, keep my limit statement there for now. Derivative on the top and the derivative on the bottom. Derivative of x minus 1 is 1. Derivative of ln of x is 1 over x. Now if I plug in infinity, I'm going to be doing 1 divided by 1 divided by infinity. Or I can simplify this before I plug it in. I can make it the limit as x approaches infinity of x, because I can multiply the top and the bottom by x. That'll cancel out on the bottom. Or you can just think about flipping fractions that are on the bottom. Either way, this simplifies to just be x. The limit as x approaches infinity of x is infinity. So if I graph this function, since the top is growing much faster than the bottom, x grows much faster than ln of x. So this limit would approach infinity. All right, let's take a look at another example. So, and again, sometimes infinity divided by infinity is a number. Sometimes infinity divided by infinity is infinity. Like there's lots of different things, which is why you have to use L'Hopital's rule. Okay, if I plug in infinity, and then e to the x, let's think about the parent function for e to the x. Instead of a log, it's a reflection over the line y equals x of a log function because they're inverses of each other. So as x approaches infinity, my function is going up. And this is kind of the opposite of the last case. So limit as x approaches infinity of x, that's infinity. Limit as x approaches infinity of e to the x is also infinity. Therefore, I can use L'Hopital's rule. So this is the same as the limit as x approaches infinity. Derivative of x is 1. Derivative of e to the x is e to the x. Now when I plug in infinity, I still have infinity on the bottom. E to the x is infinity. But I don't have infinity on the top, so we're not using L'Hopital's rule anymore. Now we can just evaluate this. 1 divided by e to the power of infinity is 0. 1 divided by infinity is going to evaluate to 0 when we're looking at a limit. So all three of these problems started out as infinity over infinity. One of them reduced to a constant, one of them reduced to infinity, and one of them reduced to 0. I don't think reduced is the right word. Evaluated is what I should have said for all three of those. So when you see 0 over 0 or infinity over infinity, you're going to use L'Hopital because you can't tell what the answer is without using L'Hopital. All right. The rest of this video is just practice. So take a look at these problems, hit pause, try to work them out, check your work, and then we're going to do the same thing on these two. So just 4 more practice problems. Good luck. All right, let's see how you guys did. On the first one, you only have to use L'Hopital once, so they both evaluate to infinity. So you can use L'Hopital, reduce it to 3 over 3x squared minus 7, and then when you plug in infinity on the bottom, that would evaluate to be 0. On the second one, you're going to have to use L'Hopital twice. On the first one, as the limit approaches 0 from the right, if we think about a natural log function, as we approach 0 from the right, we're approaching negative infinity. The top and the bottom are both approaching negative infinity, so we can use L'Hopital again. 1 over x squared plus 2x times the derivative of x squared plus 2x, which is 2x plus 2, over 1 over x. I'm going to multiply the top and the bottom by x to get rid of the fractions on top of the fractions. So x times 2x plus 2 is 2x squared plus 2x, and then this denominator went down to the bottom. The bottom completely canceled out and went away. When I plug in 0 here, I have 0 over 0. Notice it's a different fraction. First it was negative infinity over negative infinity. Now it's 0 over 0. That's still indeterminate form, so we're still going to use L'Hopital. So I can take the derivative on the top and the bottom. Make sure you write out the limit statements again. Now when I plug in 0, 4 times 0 plus 2 and 2 times 0 plus 2, I don't get 0 over 0 anymore. And then 2 divided by 2 gives me my answer of 1. Notice that if you used L'Hopital again here, you would have gotten 4 over 2, which would have given you 2. And that's not the right answer because L'Hopital doesn't apply here. Make sure you write out that the limit of the top and the bottom both equal 0 or both equal infinity. In this case, those limits don't equal 0. So that's a way that you can catch yourself. Wait, I shouldn't be using L'Hopital anymore. Just evaluate it at this point. All right, let's take a look at 2 more examples. So here's the last 2 examples. Go ahead and hit pause, try to work them out, and then check in a second. All right, let's see how you guys did. Both of these problems require using L'Hopital twice. So the first one, they both approach infinity, so you can use LHOP. When you take the derivative of a log, it's 1 over. Since the base is not e, you need this factor of 1 over ln2 or 1 over ln3. Fractions divided by fractions is the same as multiplying by the reciprocal of the bottom. So I can flip this and move it up to the top. So I have not used LHOP to go from here to here. This was just simplifying. So then when I do the limit of the top, it's infinity. Limit of the bottom, it's infinity. So I can use LHOP again. X plus 3 times a constant. 3 times a constant goes away. The x plus 3, or sorry, the x times ln of 3, if you take the derivative, the x goes away and you're just left with ln of 3. Same idea down here. This is just a number. So a number times x, if you take the derivative, it's just the number. So the limit as x approaches infinity. There isn't x in here anymore. So this is my answer, ln of 3 divided by ln of 2. Down here, this could have gone with the other video series, but I just threw it in here as extra practice. Limit on the top and the bottom both approach or evaluate to be 0, so you can use LHOP. Take the derivatives, they're still equal to 0, so you can use LHOP again, and then it simplifies down to a half. Main thing to keep in mind when you're using L'Hopital's rule. First of all, it has nothing to do with the quotient rule. Just because you see a fraction, it has nothing to do with the quotient rule. The quotient rule is used to find the derivative of a fraction. L'Hopital's rule is used to evaluate a limit when you have a fraction and it's in indeterminate form. And again, indeterminate form is either 0 over 0 or infinity over infinity. And those infinities can be positive or negative. All right. Hope this video helped. Good luck and have a great day.